Our topic for today is force and stress. What is force and stress? Force is the strength or energy that is exerted that causes a change in velocity of an object. And stress is the amount of force exerted per unit area experienced by a material. When rocks are under the influence of stress, they change their shape and volume. The stress is caused by the force that is exerted from the edges or interior of a material, gravity, temperature, and the wetting and drying of the material. The physical processes that exert stresses on rocks, for example, the gravity, it constantly exerts downward stress on all rocks. For the temperature, because of the changes, it causes thermal expansion and contraction that can cause rocks to fracture. There are two principles that rocks exhibit when stress are exerted. When rocks are under the stress, they may exhibit their brittleness or ductility. Brittleness, meaning that they can fracture and fall. Alternatively, at higher temperature and pressure, many rocks flow in response to stress. This is called ductility. Let's talk about folds. In geology, folds is characterized as the undulation or waves in the stratified rocks of Earth's crust. Stratified rocks were originally formed from sediments that were deposited in flat horizontal sheets. As we can see now, the strata is no longer flat. Because of the forces and stress, the strata has been warped.
Descriptive feature of folds. Fold size. Minor folds are quite frequently seen in outcrop. Major folds seldom are except in the more arid countries. Arid is a region that is lacking of available water, which can hinder the growth of plants and animal life. Minor folds can, however, often provide a key to the major folds they're related to. They reflect the same shape and style, the direction in which the closure of the major folds lie, and their cleavage indicates the attitude of actual planes of the major folds in the direction of overturning. Actual planes is an imaginary plane that divides the body or a rock into superior and inferior parts. Fold shape. A fold can be shaped like chevron. We will discuss chevron later in this video. With planar limbs meeting at an angular axis, as cuspate with curved limbs, as circular with a curved axis, or as elliptical with an equal wavelength. Fold tightness. Fold tightness is defined by the size of the angle between folds limbs, as measured tangential to the folded surface at the inflection of each limb, called the interlimb angle. Fold symmetry. Not all folds are equal on both sides of the axis of the fold. Those with limbs are relatively equal length are termed symmetrical, and those with highly unequal limbs are asymmetrical. Asymmetrical folds are generally have an axis at an angle to the original unfolded surface they are formed on. Facing invergence. Vergence is calculated in a direction perpendicular to the fold axis. Deformation style classes. Folds that maintain uniform layer thickness are classed as concentric folds. Those that don't are called similar folds. Similar folds tend to display thinning of limbs and thickening of the hinge zone. Concentric folds are caused by warping from active buckling of the layers, whereas similar folds usually form by some form of shear flow where the layers are not mechanically active. Fold classification. Folds are classified on the basis of several geometric factors. First, tightness of folding, orientation of actual plane, and thickness of folded beds. This is an example of tightness of folding. This can be described as open, tight, or isoclinal. This is a representation of the orientation of the actual plane. The orientation can be upright, with the actual plane being vertical. It can be overturned, actual plane being moderately inclined and one limb being overturned, or recumbent, one limb inverted, and actual plane being near horizontal. There are two types of thickness of folded beds. First is thickly bedded. Brittle units tend to form concentric folds with the bed thickness preserved to normal bedding surfaces. Second is thinly bedded. Clay-rich units have a similar tendency to develop a foliation parallel to the actual plane and form similar folds, with the vertical distance between top and bottom of the unit preserves to the deformation. Next, we're going to discuss the different types of folds. Anticline. Anticline is characterized as linear. The strata normally dips away from the actual center, and the oldest strata is in the center. Now, what is strata? Strata is a layer of sedimentary rocks, soil, or igneous rock that was formed at the Earth's surface, with internally consistent characteristics that distinguish it from other layers. Next, syncline. Syncline is also characterized linear. The strata normally dips toward the actual center, or it dips down, and the youngest strata is in the center. Antiform. Antiform is also linear. The strata dips away from the actual center. This time, neither the youngest or the oldest strata is in the center, or the age is unknown or inverted. Synform. Synform is also linear. The strata dips towards the actual center. The age is unknown or inverted.
A dome is such a fold that is convex upward, which means that its strata dip outward from the central area. A basin is a circular fold that is concave upward, and it is the counterpart or vice versa of a dome. And it means that each strata is deep inward toward the central area. A monocline is a step-like fold in rock strata consisting of a zone of steeper dip within an otherwise horizontal or gently dipping sequence, like a carpet drip over a stair step. Fold with only one steep limb, or a one-half fold, due to blind faults in subsurface rock. Displacement folds overlying rocks. Chevron folds are a structural feature characterized by repeated well-behaved folded beds with straight limbs and sharp hinges. Well developed, these folds develop repeated a set of V-shaped beds. They develop in response to regional or local compressive stress. Recumbent fold has an essentially horizontal axial plane. Fold axial plane oriented at low angle will result in overturned strata in one limb of the fold. Slump fold. A slump fold is a form of mass twisting that occurs when a coherent mass of loosely consolidated materials or a rock layer moves a short distance toward down a slope. This results in internal deformation of the moving mass, consisting chiefly of overturned folds. Stigmatic folds have a lobate shape and look like intestines, usually found where single competent layers are enclosed in a matrix of low competence. Typically, stigmatic folds do not maintain their orthogonal thickness. Characteristically, their axial planes are curved. Parasitic fold, a fold of a small wavelength and amplitude which usually occurs in a systematic form superimposed on folds of larger wavelength. Parasitic folds usually show typical S and Z asymmetric profiles on their limbs and M profiles in the hinge regions.
Disharmonic. Disharmonic folds in adjacent layers with different wavelengths and shape. This is the end of the discussion. Thank you for everyone for listening.